expecting me to do something.
I know. All right. So 17 and 18 said estimate and approximately. All right. So when we're looking at this, when it says estimate, I estimated Cherokee to be 300,000, and then the smallest population, the Choctaw, I estimated to be 5,000. So that difference would be 225,000. Was yours close to that?
I had exactly that.
Okay, great. All right, 18, approximately what percent? Because we're going to have to estimate again because these bars aren't perfect. What was the percent of the population that was Cherokee? So I would say Cherokee looks like it's pretty close to 300,000. Over, then I found the sum of all the rest of them. So I said this was 300, this was 100, this was 75, this was 275, this was 110 is what I estimated it. And so I got 300 over 860, which is approximately 35%. Was your percentage close to 35%?
I said 25. I said 35%.
I said 33.3.
Okay. If yours was I'd say an error of plus or minus 2%, you're good. Okay. 19, did you get Friday? And 20, Wednesday.
Yes.
And 21 is 3.5 times. Of course, hopefully you noticed that this first S represented Sunday instead of this one, because this represented your day. Okay? 22 was games 1 and 2, and 23 was games 3, 4, and 5. Any questions?
I got that right.
No.
Oh my God.
Good. All right, let's move on then. 24, 32.50. 25 would be stock Y changed the most, and it changed the most between April and July. And 26, you could have said many different things. They both had an increase over time. Both of them had a dip and then increased over time. You could have said something like that. 27, to get to 8 and 1/3%, we would have find how many cars are hopper cars. So the hopper car was 8. Add up to find the total number of cars, and divide those two. And you should have got 8 and 1/3%. Did you? Now, what percent of the total number of cars are gondola or tank cars? So you would do the gondola and the tank car, and then divide it by the total. I'm not extremely familiar with different train cars, apparently, because gondola makes me think of Venice and getting on one of those little boats and going for a ride down a canal.
That sounds fun.
You know, I went this summer, and I think it would be fun if you were like the only person on the gondola going down the canal.
Is there more than one person?
But yes, it's like just lots of people in the gondola going down the canal.
Is there like an Italian guy driving with like a stick paddle?
Yeah, they are.
Are you being racist?
We are recording. Yes, it does go like that. You actually have to pay extra to have the guy sing to you.
Really?
Number 29. Why is a double line your best choice here? Because it is change over time. And so I should have seen something like this on your paper. That's why when I walked around I didn't see a graph at all. I was confused. Okay, so number 29 should have had a nice little graph.
Mine was big.
And it should look something like this. Now, I wouldn't say a bar is wrong, but it's not the best choice because this represents change over time, and it has to be a double line because we have two sets of data here. All right, number 30, I would have chosen line because it's change over a time period. Did you choose line?
Yes.
Okay, now 31 is two sets of change over a time period, so it should be a double line.
Yes.
All right, this one we're comparing all the different carnivals, so it should have been a bar. And on this one, we're comparing one age group to the whole thing, part to whole, circle. Yes, Andrew.
On our test, are we gonna need to remember? I guess
Our test was a long ways away.
Properly choose the right answer? That's always a good idea on a test, to properly choose the right answer.
All right.
Yes.
That's the date that our test is on. Nice job.
Okay, and then the last two. we are looking at one player compared to the team, part to whole. Part to whole is circle. And on this one, we're doing 75% more than we got at age 40. Well, age 40, we received 4 magazines. 75% of that is 3. 4 plus 3 is 7. Therefore, it's 30. Okay? Any questions about the homework?
No.
Okay. So, yesterday we talked about, what did we talk about?
Well, we
talked about yes, quantitative versus qualitative. So, qualitative, we said we would graph using the circle graph, the bar graph, or the line graph. And today we're going to start taking a look at ways to graph quantitative data. And today we're going to look at histograms. All right, take out your little half sheet of notes that I've given to you all.
Which I have.
And I am going to copy this page for those of you that are looking at this online right now. That way you can print it out if you want to. So that way you'll have a blank copy. And you can work with us. Okay. So, the following sample data set tests the number of minutes 10 internet subscribers spent on the internet during their most recent session. So this would be like if you had to log in to use the internet. Maybe if you were like on a cruise and you had to log into the little thing and use your minutes to use the internet. This would be what this would represent. Otherwise, you're not usually like at home. You're not timed on internet usage. But here we have different minutes. So first thing we're going to do is we're going to determine the number of classes. And this is something that I will tell you. Now, generally we would use between 5 and 20 classes. And we can pick depending on how we want our to look. The reason I tell you the number of classes is so that when I grade it, I don't have 26 different looking correct histograms. It would take me forever to grade them if I let you all choose a different number of classes. So I'm going to say we're going to do 5 classes. So we're going to divide this up into 5 different ranges for time periods of usage. So to find the class width, every time what we'll do is we'll take the maximum value, subtract the minimum value from that, and divide by our number of classes. So in this case, what is the maximum value? 100 minus the minimum value, 7, divide by the number of classes. So when we take 100 minus 7, this is 93. And 93 divided by 5 is 18.6. Now, here it says we always round up. So even if it were 18.2, we round up to 19. So we're going to say our class width is 19. We always round up instead of down so that all of our data will actually fit into our classes once we're done. If we round down, sometimes our last class is not large enough to contain our highest value. All right, now what we're going to do is we're going to find the lower and the upper limits for the classes. Now this is the way I do it. I always start with whatever the lowest value is on the chart, 7. Then we determined that the class width was 19. So I would not add 19 to this 7 to see where the next class would start. What is 7 plus 19?
26.
26. What is 26 plus 19?
35. I completely messed that up.
What is 45 plus 19?
65.
Are you?
All right, no, that's okay. We've had...
Yeah, you are.
I'll be honest with you, 19 is a hard number for me to add by, but you know what's real easy to add? 20.
Minus
And then
1.
take away 1.
That's what I was trying to
So 64 plus 20 is 84, take away 1 is 83. All right. So this one would go from 7 up to 25. And that may bother some of you. And let me do a timeout right here.
Right now.
We said the class width was 19, which means it should hold 19 pieces of data, right? What is 25 minus 7?
18.
18. Okay, So that doesn't look like it is 19, does it?
No.
Okay, I'm going to need to borrow your hands for just a second. All right, here we go. Let's count. I'm going to start with 7. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now I need you. Put up 10. Okay, I was at 16. She's doing my 10 now. 17, 18, 19, 20, 21, 22, 23, 24, 25. Her 10 and my 9 make how many?
19.
19. Well, why did we get 18 when we subtracted?
Something fishy is going on.
Numbers
Right.
Really suspicious.
When we just subtract the 2, we're not counting the 7. When we subtract the 2, we're taking the 7 out of the mix. Do you see when we do 25 minus 7, we're taking the 7 out? But we need to include that 7, don't we? So you can't just subtract the 2 to see it. You would actually have to subtract 1 less. So that's a tricky little concept, but you know what always works? Does it bother you?
Yeah.
Yes, it has bothered me many times. Like, you know that the numbers 1 through 10, there are 10 numbers.
Yeah.
You don't go 10 minus 1 is 9. You know that's not 9 numbers.
Yeah.
See, that doesn't bother you. But when I switch the range to a different, we just want to subtract and we can't do it. So, all right, so what we do, did y'all see what I did? I started here, and where did I add the 19? To get to this number. And then added the 19 to get to this number. And then added the 19 here. Okay?
See.
All right. So if this goes up to 45, then 44 is the last one here, and then 63 is the last one here, and this one starts at 83, so 82 ought to be the last one. So do you see it really looks like I'm adding 18? So that would take us to 101. All right, now, if we had a lot of data, and our data was not organized, so it wasn't in increasing or decreasing order, we would definitely want to do tally marks to count, to see how many fell in each range. But this is a very small data set. 10 pieces of data is not really enough to work with. But that's what we have. So we may not need tally marks for this. Because how many pieces of data fall in this range from 7 to 25? Well, 1. One tally mark. So this little F that's italicized represents frequency. Doesn't frequency just mean to count? Well, there was only 1. Okay, now 26 to 44. 26 to 44. No. 1. There's only 1, so the frequency is 1. Okay, 45 to 63. There's 1. There's 2. And that's it. So there's 2. 64 to 82. 1, 2, 3.
Yeah, that's 3 of them.
And then finally, 83 to 101. 1, 2, 3. Okay.
It's like a pattern.
It was kind of like a pattern, wasn't it? It's symmetric about the 2.
See.
All right. So we have 1 plus 1 is 2, plus 2 is 4, plus 3 is 7, plus 3 is 10. Did I start off with 10 pieces of data?
Yeah.
Yes. That's a good way to check and make sure you didn't miss any of them. If you add up your frequency, it better equal your total. All right, now, this is all our descriptive statistics, where we're taking the information and we're displaying it graphically. Now, we could take this information later on and make inferences, inferential statistics based on it. And at that point, we would need the midpoint. Now, the midpoint is easy to find. The midpoint of each class is found by taking that lower bound, adding the upper bound to it, and dividing by 2. So what is 7 plus 25?
2.
Divide by 2.
16.
26 plus 44. 70. Divided by 2. 35. 45 plus 63. 108. Divide by 2. 54. You guys, look at this. Do you see it's going up by 19?
Pattern.
Yeah.
Why do you think?
That is crazy.
Maybe because our class width is 19.
Ah, exactly. So what would the next one be?
60.
Whoa, 73, 73.
73.
And then
92.
92. Good.
Great job, Ed.
So
We would get the same thing if we added these two and divided by 2 also.
class width always in the mid.
I guess so.
Or
The difference in midpoints is always the same as the class width. Now, tomorrow we're going to come back and check out relative frequency. But today we're just creating histograms, giving a frequency distribution. And when I ask you for a frequency distribution, that is this table. The table is a frequency distribution. It shows us how our data is distributed. Does that make sense? And this is how our data was distributed. We have 1 that falls between 7 and 25, 1 between 26 and 44, 2 here, 3 here, 3 here. All right, now let's look at it graphically. I wonder if I could copy all of this. This is not going to work, but I'm going to give it a try. Edit, copy, and then if I could
Wait.
go over to the next page and go paste.
That'd be pretty cool.
Oh my god.
Oh, I didn't put it in the right spot, but it is helpful. I can shift it. I can shift.
You can shift that. She shifted it.
Wow.
Okay, that worked out beautifully.
That's sick.
That was
That's
cool.
nice.
That was
Okay,
really cool.
now if you notice that your paper only has one graph on it, that's because I was sitting there this morning thinking, I need a little extra that talks them through the steps. I'll do this. And then I sent it to the printer. And then I went, oops. I really wanted 2 graphs. Because today we're doing a frequency histogram. And tomorrow we're going to do relative frequency. So tomorrow you'll just have to draw another one up under the one you have on yours. Okay, not a big deal. So we're supposed to sketch the histogram and with a title and labeled axis. So our title, this has something to do with internet usage. So how about internet usage? Original, isn't it?
Promethean is a vocab word.
What does Promethean mean?
Creatively original. No, originally creative.
I saw that.
All right, now we'll label our axis. On our horizontal axis, what we're going to do is we're going to put these classes we just found. So what did our classes represent? It represented the time we used the internet, and that time was in minutes, wasn't it? So we're going to label that axis so that when we look at it, we know what's going on. Now, because this doesn't start at 0, my first little bar, I'll probably start over a little bit since it doesn't start at 0. And so I'll say that this is going to go from 7 to 25. And you'll be able to write a little smaller than I can because you have a pencil and not a Moby pen. So the next interval goes from 26 to 44. The next interval goes from 45 to 63. The next one goes from 64 to 82. And our last one goes from 83 to 101. And then along the other axis, this is just our frequency, our count. And since it only goes up to 3, I could go 1, 2, 3. Or I could count by 0.5s, I think would even fit. Doesn't matter, either way is correct. And then what we're going to do is we're going to draw in, probably best to do this with a ruler. Draw in our bars. So the first one goes up to 1. I missed it a little bit, so I'm going to shift it down. There we go.
All done.
Oh, no. Bad.
Please don't, man.
You want it?
All right. And then our second one needs to go up to 1. Nice little bar that goes up to 1. And they should be touching, right? They should be touching.
But yours not.
That's because I'm using the tool on the Moby.
Oh, yeah.
But yours should. And then the next one, we had a frequency of 2, so it needs to go up to 2.
I think so.
Oops. And then the next one,
Trace.
3. Good. Take it up to 3. And then the last one, 3 also. Woo.
Interesting.
You like that one?
He's a big one.
What?
Ooh, he called you man.
I call it. No,
Legit.
it's not.
And it's
I honestly don't give a.
We're being recorded.
I know myself.
words.
I think he was gonna say crud.
That's no true fact.
Yeah, Kyle never
He
said
started
All
with
right.
It's the cleanest mouth.
I mean, seriously, I can't think of anything else besides crud he would say.
Well, good. I'm glad you can't.
Wait, Kyle.
Okay.
What else would you say?
Let's take our books now, our workbooks, and open our workbooks to page
That's a lot of numbers.
321.
No, I wanted to do my homework.
321.
I have a question.
Yes.
Do you hate us? Because we gave you this a lot of words.
No, this is not a lot of work. You're about to see how simple this is.
Want you to show me.
By the time you went there and got back, I'd almost be done. So just kind of watch it and you can print it out later.
No, it's good.
Okay. All right. We're going to do 5, 4, 3, 2, 1. All right. Example 1 is creating a histogram. We're on page 321. It says listed below were the ages of 100 U.S. senators at the time of the 112th Congress. Began on January 3rd, 2011. Create the histogram for this data set. Now, it gives us here. We're kind of not going to follow those because I want you to do it the way I just instructed you. It's going to be the Willoughby way. Once again, the Willoughby way is not the only way, but it does help us to, one, get used to creating a fair histogram, and 2, it makes it a little easier for me to grade. The next one, I'm going to ask you to follow the directions in the book, though, because I want you to see that it doesn't have to have 5 classes. It could have 6. It could have 8. Generally, we have somewhere between 5 and 20. All right, so we're going to somewhat ignore this. And Evan, quit putting that on his desk for a second, okay?
It's okay.
Well, it looks like we're going to have to do this.
All right.
That's right.
So, let's go through our steps. Our steps first were to determine the class width, and we're going to stick with 5 classes here, so that'll help you determine the class width. How did we find the class width?
You subtract.
You subtract what?
Max min over max
Min over the
Okay.
class.
Okay, so maximum value minus the minimum value divided by the number of classes. So what is 86 minus 39 divided by 5?
I get my calculator out and do that.
45. 47.
86 minus
47 divided by
39.
47.
47 divided by 5.
9.4.
So then it's like
9.4.
Nine.
10. No, you didn't get it.
Okay,
I didn't
good.
use a calculator.
Very good. So when we divide this, we get 9.4, but we always round up. So we're going to round up to a class width of 10. So that's what my class width will be.
Nice.
Okay, so we're just going to pretend like this wasn't here. You scratch it out. And so we're going to start with our lowest value, which is 39. And so we're going to add 10 to this all the way down. So what is 39 plus 10?
49.
Plus 10?
59.
Plus 10?
69.
And plus 10.
79.
Okay, now do you see how your book started at 30? And there is no value of 30, is there? But that's completely fair.
That was almost bad. That almost turned bad. Close one.
No,
We're not
it's
doing
okay to
that.
write a wrong number and erase it. Fix it. That's fine.
Unless it's in bad.
Okay, so what I was saying was your book goes from 30 to 39, and the next one from 40 to 49. That's what it would be. Now, that is totally fine. It can completely be set up that way. It's just going to look, the shape of the distribution will look a little different. But you just have to be clear on what your intervals are here, and it can still be correct. All right, so this would go from 39 to 48, and then this would go to
58.
68.
68.
78.
78.
Oh my gosh.
and 88. Now, the really nice thing about this data is it is already
And enter.
in order. It's so easy. We don't need, do you see there's not even a column for a tally? We don't need one. We can just count.
Great.
So we're going, divide it up from 39 to 48. Count how many there are. From 49 to 58. From 59 to 68. From 69 to 78. And count those. Let me make that look a little more like a 5. There we go. Might be easier to count it in your book than on the screen.
Oh, that's fine. Alright,
I remember when I was in kindergarten, so I'm the first
let's
one.
do this. Oh.
I actually didn't say I was the first one though.
Ooh, you got one of them wrong.
You was up to 100.
Yep, it's yours. That's all.
Okay, so what do we get here?
9.
9, and then
29.
9.
38.
9.
21. 3.
excellent. Okay, so this is our, what do we call this? Our frequency
Chart.
distribution.
Table.
So that's called a frequency distribution.
It says table.
And it is a table, yes, yes. But as we get into statistics, we're going to talk about the distribution of data. How is the data spread out? Where is it? What does it look like?
it's easier to call
And so
that.
they'll use the word distribution a good bit.
So we're familiar
Whoop.
with it.
Now I'd like you to, yeah, that was the answers. Go ahead and flip over to the next page, and we're going to white out the little part that's here. And do you see it would just look like this? 39 to 48 would be up to 9. 49 to 58 would go all the way up to 29. 59 to 68 would go all the way up to 38. And it would look so bad.
It's really not that hard.
It is not hard.
29.
Now, we certainly could do 6 classes. And they certainly could start at 30. Just like the book said. It's not wrong to do it that way.
You do it. It's okay to do it like 5 classes all the time.
I usually draw this one.
I do 5 classes a lot. Just in here, if you were to take a real statistics course and look at more data, you would choose different classes.
How would you know what class to choose?
You would be taught that they needed to know before you would choose.
Do you know that answer?
Sometimes I do. Statistics is not really my strong suit.
I know this guy that finished statistics.
I did take 6 graduate level statistics courses though.
What? That's a lot.
That's a lot, yeah. That's like 6.
That's like 6, yeah.
Wow.
But it's still not my favorite.
So why did you take
Algebra,
6 courses?
algebra and calculus
Is that where you teach
are my favorite. The reason I took it is because I had to, I got my master's when I was doing my student teaching. And so I would teach all day long, and then I would go to school at night. And so I had to sign up for the classes they were offering.
You know, I hope that you can teach me how to find an instantaneous rate of change. I would like for you to teach me that.
I don't know that I will be your teacher then.
Can you be? Is
It's
it
possible.
We're making histograms.
Yeah, but that's what we're doing right now, making histograms. Okay, so let's flip over and do this one. So this represents the data, the age of the presidents upon inauguration, right? And so we have the 44 presidents here, and they have already set it up. And so I want us to now try one that's not 5 classes. This one is actually 6.
page is this?
So let's go with it. Let's leave it in 6 classes. And they have already determined what our class width is, haven't they? What is our class width?
4.
5.
Yep. Woo.
From 41 to 45 is 5. So the next one would go from 46 to 50. And then 51 to 55. And then 56 to 60. And then 61 to 65. And then 66 to 70. And so we would count our frequency, and then we would graph our information. Please finish this one
By the end of class.
in the next couple of seconds.
Okay. Sweet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know I did it on actually.
Yes, sir.
Oh, do we have to find the relative frequency on the table, or?
We are not doing the relative yet. Tomorrow we will pull some of these back out and look at the relative.
Alright.
Okay, when you've wrapped it up, look up at the board and see how you did. Do you see, even if we used our method where we take the largest piece of data minus the smallest and divide, we get a class width of 4.5, which would round to 5. Is that the same class width they used? Why, yes it is. All right, does yours look similar to mine? Excellent. All right, your homework is out of the workbook. It's pages 325 and 326, all the problems. I'm going to let you go ahead and get started on that. And if I notice that you're working well, you would receive your test back to look at today.
I'm